This is Mr. Martin, and these are the second part of the notes for Section 4.1, Day 1. So Section 4.1, Day 1, Part 2. We're going to look at a few examples now. So for the first examples, we want to determine the quadrant in which each angle lies. And we're going to always assume that the angle is in standard position. So again, standard position, the initial side is on the positive x-axis. So I always like to make a little sketch. So I'm going to start with my coordinate axes, and I've got my initial side. Let's try that again. So here's my coordinate axes. I've got my initial side on the positive x-axis. I know we have negative 205. So negative 180 would go to here, and then I need to go another 25 degrees. So I'm going to go a little bit over to there, and here's going to be the terminal side. So here's my angle, negative 205 degrees. Again, it's going clockwise, which is the negative direction, and then we see that we're in quadrant 2. Alright, let's take a look at 6 pi over 5. So again, I like to make a sketch. So here's my coordinate axes, and since we're dealing with fifths, I like to mark my quadrant angles in terms of fifths. So we would start at 0, and if I went all the way around, it would be 10 pi over 5. That would give me my 2 pi. So halfway around would be 5 pi over 5, which means a quarter of the way around would be 2.5 pi over 5. And then 3/4, so 270 degrees, is going to be 7.5 pi over 5. So a little shortcut here, if I take the 90 degrees and the 180 degrees, 90 and 180 is 270. So if I add these two, that's going to give me the 3 pi over 2. So 2.5 and 5 gives me 7.5. So then I could see that 6 pi over 5 is going to be 1 pi over 5 past 5 pi over 5. So somewhere over here. So here's my initial side, positive rotation, which is counterclockwise. So I see that I am in the third quadrant. Again, as always, if you have questions as you go through the notes, make sure you write them down in the margins and ask me when you get to class. Alright, next example, we want to convert each angle to radians and leave in terms of pi. So we know that our conversion factor is that pi is equal to 180 degrees. So we need to decide whether we're going to use this in fractional form, so we want to decide if the pi needs to go into the numerator or into the denominator. So we want to convert from degrees, so I have 120 degrees. I'm going to put that over 1, and then I'm going to multiply by pi over 180. So now my degrees, units of degrees, are going to cancel out. And then when I multiply this through, 120 over 180 reduces to 2/3. You could also plug that into your calculator and hit math number one, math enter, enter. And that will change it back to a fraction for you if you don't want to reduce it. But that's going to end up being 2 pi over 3. Okay, let's try the next one, negative 144. So I have negative 144 degrees. Again, I'm going to put that over 1. And then I'm going to multiply by pi over 180. Again, the 180 is going in the denominator, so I know that the degrees in the denominator and the degrees in the numerator are going to cancel. And 144 over 180 is going to reduce to 4/5, so this turns out to be negative 4 pi over 5. Alright, again, write down any questions you have. Make sure you ask me in class. Next example, we want to convert each angle to degrees. So now we're going to take our conversion factor and we're going to flip it. So now I've got 7 pi over 4, and I'm going to multiply by 180 over pi. So you see the pi's are going to cancel. This 4 is going to reduce with that 180 to give us a 1 down here and a 45 over here. And then I have 7 times 45, which is 315 degrees. Now, denominator here for part B of 13 is not really going to give us an exact answer unless we leave it in improper fraction. So we've got 8 pi over 13. Then we're going to multiply again by 180 degrees over pi. So these pi's again are going to cancel out. And then if we multiply this through and leave it as an improper fraction, we end up with 1,440 over 13 degrees, or if we approximate it as a decimal, we get 110.8 degrees. So there's our answer for that one. There's our answer for that one. All right, next example. We want to find a positive and a negative coterminal angle for each, and we want to graph all three angles. So I'm going to start by graphing the original angle. So I've got negative 110 degrees, so that's 20 degrees more than negative 90, so it's going to be somewhere over here in the third quadrant. And it's negative rotation, so that's clockwise, so this is going to be theta. And then I think it's easiest to draw the other coterminal angles. So now I know, remember coterminal, it starts and ends in the same spot, so we need to start on the positive x-axis and we need to end at the terminal side of 110 degrees. So if I go all the way around this way, starts at the positive x-axis, ends at the terminal side, we have a coterminal angle, and we're going to have to figure out how much that is. And then the last one, I've got a negative angle that we're given, I've got a positive coterminal angle, and then I'm going to find one more coterminal angle. Usually I'll go in the same direction as the original problem, so since the original one is negative, I'm going to go in the negative direction. If I go just to there, I've already got that angle, so what I need to do is go all the way around and then continue until I get to the terminal side of the original angle. So I'm going to call this angle here alpha, and I'm going to call this angle here beta, and now we're going to calculate how much those are. So we can see that if I add the absolute value of theta and alpha, they make the full circle, so that's going to be 360 degrees. So alpha's got to be whatever is left of the 360 degrees. So alpha is going to be negative 110 plus 360, so that gives us 250 degrees. And then I see that beta goes 360 in the negative direction, and then it goes another 110, so it's 360 plus 110. I'm going to write it as negative 110 minus 360, so that gives us negative 470 degrees. So we have one positive and one negative coterminal angle. Moving on to part B. For this one we've got 12 pi over 11, so what I like to do is mark my quadrant angles, so I know that halfway around is going to be 11 pi over 11, so that's my pi, and then 360 is going to be 22 pi over 11, which would make 90 degrees, 5.5 pi over 11, and then this would be 16.5 pi over 11. So our original angle, which I'll make in red again, is going to be 12 pi over 11. So it's 1 pi over 11 past 11 pi over 11. So it's 1 pi over 11, 12 past pi. So it's going to be somewhere over here. Here's my initial side. I'm going to draw in the direction. So that's theta. And then I'm going to draw in my other two angles. So I know that my next angle has to go the opposite direction and end over there at the terminal side in the third quadrant. So that'll be my alpha. Again, it doesn't really matter what variables you use for them. I just tend to use alpha and beta. And then we need one more angle. Again, we've got a negative one, so we need one more positive. So I'm going to go over here to 12 pi over 11, but then I'm going to keep going all the way around until I get back there again. So I pass it and then go another 360 degrees until I get back to it. Alright, so let's go ahead and calculate what we've got here. I've got alpha is going to be 12 pi over 11, and then I need to subtract 22 pi over 11. Okay, so again, remember that the alpha and the theta, they add up to 360, which is 22 pi over 11, so we have to figure out what's left here. So that gives us negative 10 pi over 11. And this green angle here, that was my beta. So I've got beta is equal to 12 pi over 11 plus 22 pi over 11, or 34 pi over 11. So if you take a look, it's important that you understand what's going on in the graph. Again, the alpha and the beta in this case, and the alpha and the beta in this case, those two angles add up to 360, or the whole circle. And then the swirly green one is 360 plus the original angle. Okay, in this case it happened to be in the negative direction, so it's plus negative 360. But essentially what's happening here is we take our original angle and we're going to add 360 to get one angle, or we're going to subtract 360 to get another angle. Same thing here. We subtracted 2 pi, we added 2 pi. Now sometimes if you don't get a positive and a negative by adding and subtracting, you may have to subtract twice, or you may have to add twice. But you'll see how that works when you do some more example problems and some practice problems. So write down any questions that you have, ask me in class, and we'll see you next time.